This is lesson 6.3, writing and solving two-step equations. Our goal is to solve these equations with two different kinds of operations. Two-step equations are exactly that. It's going to take two steps, or we'll see two steps within the equation. So, in order to solve these equations, we need to do them in two steps. Step one, we're going to simplify the equation first by using the inverse or opposite of addition or subtraction that we see in the equation. Step two, we'll simplify the equation further by using the inverse of either multiplication or division that we see within the equation. I also want to point out too, if again we see a fraction as a coefficient, we can also use what's called the reciprocal property to isolate the variable. And we'll talk more about that when we see some examples with them. So let's get into our examples. We have two of them on this slide. We have 5x minus 6 is going to be equal to 24. So in our step one, I'm supposed to take care of doing the inverse of either addition or subtraction that I see in the problem. Well, in this problem, I see subtract 6. So that's the first thing I'm going to deal with. So the inverse of subtract 6 is going to be add 6. So step one is I'm going to add 6. And when we're working algebraically, we want to do the same thing to both sides of the equation, because if we do the same thing to both sides of the equation stays in balance. So if I add 6 to the left-hand side of the equal sign, then I also have to add 6 to the right-hand side. So in doing so, a minus 6 and a plus 6, they will cancel out to give you 0. So what's left on the left-hand side is 5 times x, or 5x. When I add 6 to 24, I get 30. So now my new equation is 5 times some number x is equal to 30. So step two, I have to do the inverse of either multiplication or division. I see 5 times x. So 5 times x, the opposite or inverse of times 5 would be divide 5. So I'm going to divide both sides by 5. Whatever I do to one side of the equation, I have to do to the other to keep it in balance. 5 divided by 5 would be 1x. 5 divided by 5 is 1. So 1x, I simply just write the letter x. And then we have 30 divided by 5 on the right-hand side, and 30 divided by 5 is 6. In order to check my solution to make sure that it balances, I simply take my 6 and I plug it back in for the x term in the original equation. So 5 times 6 minus 6 should be equal to 24. I'll use the order of operations now to check my solution. So I have to multiply 5 times 6 first. Then I'll subtract 6 to see if it balances. 5 times 6 would be 30, and 30 minus 6 needs to be equal to 24. So we'll see here that 30 take away 6 is 24. So the solution to my equation checks out. And so that's how I prove that 6 is the correct answer. Our next equation, we have 9 times y plus 5 is equal to 77. I apologize for the equal signs not matching up. With the program that I have, some error occurred. So anyway, here's where the equal sign needs to be. So step one, I'm going to find out and take care of the inverse of either add or subtract. I see plus 5, so I'm going to subtract 5 from both sides. A positive 5 and a minus 5, they make 0. So all that's left is 9 times y is equal to 72. Now I need to do in step two, take care of the inverse of multiply or divide. I see 9 times y, so I'm going to do the inverse of times 9, which is going to be divide by 9. Whatever I do to one side, I need to do to the other side of the equation. 9 divided by 9 is 1y, and 72 divided by 9 would be 8. So I have solved y to be equal to 8. To check my answer to see if the solution works, I plug back in 8 for y is 9 times 8 plus 5, the same as 77. 9 times 8 is 72, and 72 plus 5 is 77. So my solution checks out. Let's take a look at two more equations. This time you'll notice you'll see division in them, d divided by 9, or z divided by 0.25. So, in our first one, d divided by 9 minus 3 is equal to 3. Step 1, I'm going to add 3 to both sides because I have to take care of the inverse of addition or subtraction first. A minus 3 and a plus 3 equals 0, so I'm left with d divided by 9 is equal to 3 plus 3, which is 6. Step 2, I have to do the inverse of multiplication or division. In this case, I see division, so the inverse of division is multiplication. So I'm going to multiply both sides by 9, or 9 over 1. So the 9's here, if I'm multiplying fractions together, we've worked with the skill of canceling diagonally. So I can divide both numbers by 9. So 9 divided by 9 is 1, and down here I get 1. So 1 times d is d, and 1 times 1 is 1. d over 1 is the same thing as d. And over on the right-hand side, I'm going to take 6 times 9, and I'm going to get 54. So I've found out that d is equal to 54. Plug it back in for d. 54 divided by 9 minus 3 should be equal to 3. 54 divided by 9 is 6. 6 minus 3 equals 3. So my solution checks. In our second example, I have z divided by 0.25 minus 5 would be equal to 29. I'm going to add 5 to both sides first. Negative 5, positive 5 give you 0. So z over 0.25 has to be equal to 29 plus 5, which is going to be 34. So next I'm going to multiply both sides by 0.25. And when I do that, the 0.25s will cancel out, so I'm left with, over on the left-hand side, would be z. And 35 times 0.25 is going to equal 8.5. And here it's perfectly fine to use a calculator to get that answer, as those will be allowed for evaluation of algebraic equations. Plug in 8.5 for z. 8.5 divided by 0.25 is going to equal, or I should say minus 5 needs to equal 29. 8.5 divided by 0.25 is 34, and 34 minus 5 is going to equal 29. So I see here that my solution checks. In our next two examples, now you see we have the fraction coefficient. I have a fraction 3/8 times a variable. So here we're going to use that reciprocal property that we talked about earlier on. So I have 3/8 times w minus 14 is going to be equal to 10. Still do the same two steps. I got to deal with addition or subtraction first, so I'm going to add 14 to both sides. In doing so, the 14s make 0, so I'm left with 3/8 w is equal to 24. Now, because I have a fraction coefficient, we learned that any fraction multiplied by its reciprocal is 1. So, again, the goal is to get 1w all by itself. Well, if I multiply this 3/8 by 8/3, again, I can cancel out here the 8s, and I can even cancel out the 3s. And when I do that, I'm left with 1w, or just plain old w. So if I multiply 8/3 to one side of the equation, then I also have to do and multiply the other side of the equation by 8/3. In order to do that, I can put 24 over 1, so then I can have a fraction times a fraction. In which case, again, I like to point out that I like to cancel diagonal numbers. I can divide both of these numbers by 3. So in doing so, 3 divided by 3 is 1, 24 divided by 3 is 8, I can go top times top, bottom times bottom, and I get 8 times 8, which would be equal to 64. So W is equal to 64. Plug that back in for W. 3/8 times 64 over 1 minus 14 has to be equal to 10. So again, I'm going to use my canceling here. 8 and 64, I can divide them both by 8. 8 divided by 8 is 1. 64 divided by 8 is 8. So top times top and bottom times bottom. 3 times 8 is 24. 1 times 1 is 1. So 24 over 1 is 24. Minus 14 needs to be 10. So you see that my solution of 64 checks because I get 10 is equal to 10 when I check it. Our next equation, we have 2/3 times s minus 1 is equal to 5/6. So again, addition or subtraction is always first. So I'm going to do the opposite of minus 1. So that's add 1 to both sides. So I'm left with 2/3 times s has to be equal to this 5/6 plus 1. So I could easily take 1 plus 5/6 and make it the mixed number 1 and 5/6. I could also turn it into a decimal. But because I have a fraction here on this, I want to make this answer over here a fraction that's has a top and a bottom only, or what we call rational form, one number over another number. So instead of adding 1 in the traditional way and just throwing the fraction next to it, I'm going to change this 1 and make it 6/6. And 6/6 plus 5/6 is going to be equal to 11/6. So step 2, I'm going to deal with this coefficient 2/3. I'm going to multiply both sides by the reciprocal. So the reciprocal of 2/3 is going to be 3/2. Multiply both sides by 3/2. 3's cancel out, 2's cancel out, s is all that's left. Over here I can cancel the 3 and the 6, divide them both by 3 to get 1 and 2. So my answer now becomes 11 times 1 is 11. 2 times 2 would give me 4. My answer would be s is equal to 11/4. Now it would be if my answer is as an improper fraction, or I could turn it to a mixed number and say that that's 2 3/4. If you used a calculator, you'd get 2.75. And all three forms are perfectly fine, any one of them. So I'm going to plug in 11/4 back in for s. 2/3 times 11/4 plus 1 better be equal to 5/6. 2/3 times 11/4, I can cancel the 2 and the 4, make that a 1 and a 2. 11 times 1 is 11, and 3 times 2 is 6, so I got 11/6 plus 1, which we know is 6/6. Oh, and by the way, this is subtraction, not plus, so that's minus, so this is minus. So 11/6 minus 6/6 is going to equal 5/6. So my answer checks. In our next two examples, we're going to deal with doing a multi-step approach. So earlier in chapter 5, a chapter ago, we learned about the distributive property. And that is when we have a number outside of a set of parentheses. And inside the parentheses, we either have two numbers that we want to find the sum or add, or we want to find two things that we subtract. So we learned back in chapter 5 that in order to expand this distributive property out, I need to multiply the 3 to the x and also the 3 to the 1, and whatever operation I saw in the middle, I'm going to add when I multiply those two together. So 3 times x is going to be 3x. I see plus right here, so then I'm going to have plus in my equation, and then I'm going to take 3 times 1, and that is 3. So this distributive property right here can turn into 3x plus 3, and that all has to be equal to 12. Well, now I'm back to what we've been doing in the previous slides. I got a two-step equation. I'm going to subtract 3 from both sides. 3x then would have to equal 9. 3's cancel out. 12 minus 3 is 9. Then I'm going to divide both sides by 3, which is the coefficient. X then is going to be equal to 3. I can check out my answer by taking my 3 and plugging it in here for x. 3 times 3 plus 1 needs to be equal to 12. Now I can use either the order of operations or I can use the distributive property. Again, it really doesn't matter. So I'm going to use the order of operations, which means I have to do what's inside the parentheses first. So 3 plus 1 is 4, and 3 times 4 equals 12. So I know that my solution of 3 checks out. In our next example, we have 5 times the difference of w and 2, difference meaning subtraction, has to equal 65. So again, I see the distributive property again. So I'm going to take 5 times w to get 5w. I'm going to take 5 times 2 and get 10. And I have a subtraction sign now in the middle, so that means I'm going to subtract the 2. And then that needs to be equal to 65. Two-step equation. I'm going to add 10 to both sides. And when I do that, I'm going to get 5w is equal to 75, as the 10's make 0. And then I'm going to divide both sides by the coefficient 5. Again, remember the number out in front of a variable is called the coefficient, and that's the last step. So then in doing so, x is going to be equal to 15. Again, you can use your calculator to do that. Plug 15 back in for w. 5 times 15 minus 2 needs to be equal to 65. Again, I'm going to use the order of operations. So I could go inside the parentheses first. 15 minus 2 is 13. 13 times 5 is 65. So I know that my solution of 15 checks. We have 2 more slides for today that we're going to take a look at. And this is now taking our skill of solving these two-step equations and now applying it to a problem-solving situation. So we'll get on with the problem here. Bicycle repair. Your bicycle needs to be fixed, and a mechanic is going to charge you $40 per hour of labor, plus he's going to charge you for the new parts. That's going to cost you $35. The total cost of fixing the bike was $95. How many hours did the mechanic take to fix the bike? So in order to solve these kind of problems, the first thing we need to do is write a verbal model. And in doing that, we just want to know, what do I need to do to find out a total bill of something of this situation? Well, a mechanic is going to charge you for his labor. Then he's going to add in the parts that it took to fix the bike, and that's going to equal the total cost. And we're not going to figure in taxes or any of that kind of stuff. We're just going to deal with the money before tax. So now we need to take a look at, well, what does the mechanic charge for labor? And it says here $40 per hour. So when we look at that word per, we know that that is a multiplication type of word. So I'm going to have to pay $40 for every hour that the mechanic works. So that's going to be represented by 40 times the number of hours that the mechanic works. Then I'm going to add in the parts, and when I look at that, it costs $35 for the parts. And I know then that that's going to equal the total bill, which I was given as $95. So here's my two-step equation. 40 times the amount of hours worked plus 35 would have to equal my total bill of $95. The other thing I want to do is identify and define the variable in my equation. Well, h is my variable in the equation, and h is representing the number of hours. So I'm going to say h is equal to the number of hours the mechanic worked on the bike. So I had to identify the variable, and then I had to define it and tell it what it stood for. Now I'll go on to the final step, which is just simply solving the two-step equation, which we've been doing in this whole lesson. So 40 times h plus 35 needs to be equal to 95. I'm going to subtract 35 from both sides first. And in doing that, I'm going to be left with 40h is equal to 60. I'm going to divide both sides by 40 in my last step. And then again, you can use your calculator here, but 60 divided by 40 is going to be 1.5 or 1.5. So I know then that the mechanic worked 1.5 hours on my bike, and because he did, it cost me $95 as a total bill. Here's one more example of using those skills of writing an equation by given a word problem. You want to rent a snowmobile and go riding on trails in a local park. The company has listed, or the rental company in this case, has listed its rental fees in the chart below. Sorry, there's a typo. This should be chart. Write and solve an equation to find out how many hours you can ride, or in this case, rent the sled for, if you have $195 to spend altogether. Be sure to identify and define the variable in your equation. So again, we're going to take a look at, well, what's the first step? We should probably try to figure out the verbal model. How are you going to find out how much money you would pay to rent a snowmobile? Well, let's take a look at the table. In our table, we know that for the first hour, I just pay a simple fee of $60. So if I'm renting a snowmobile and I'm only going to go out for 1 hour, all I have to pay is $60. But I want to go snowmobiling for more than just 1 hour because it's a lot of fun. So if I look at the next part of the table, it says $45 per hour for each additional hour. So how am I going to find out how much money am I going to have to pay if I want to go snowmobiling for more than just 1 hour? So in order to do that, they're going to charge me for the first hour. Then they're going to add in any additional hours that I go. And that's going to give me then the total bill that I would have to pay. So now that I have my verbal model, now I can take a look at plugging in the things that I know. What do I know? For the first hour, it's going to cost $60. Plus, for the additional hours, I'm paying $45 per hour. Again, the word per is a multiplication word. So again, I'm going to use the letter H to talk about the number of hours. And so that's going to equal the total that I have to spend. I have only $195 to spend. So then, if I solve this equation for H, I can figure out how many hours I can ride. So, to identify the variable, H is my variable, and H is going to be the number of hours that I rent the snowmobile. So number of hours of rental. So there is identifying and defining the variable. Now I can simply solve my equation. I'm going to subtract 60 from both sides first. So I'm left with 45h is equal to 135. I'm going to divide both sides by 45. And when I take 135 divided by 45, I get 3. So what I've found out then is I can go 3 more additional hours after the first hour. So that means I will be going 4 hours on the snowmobile altogether, which sounds like a very fun time. This concludes our lesson on writing and solving two-step equations.